Different than problem number 24. What do you guys suspect we want to move towards on this? How did we address this? What do you guys think we should try to do here?
Try to get the top and the bottom even so that we can do sine. Oh, well,
Is
we
it
have
possible?
sine on the bottom.
Could you multiply it by 3 over 4?
Or could you possibly like cross out the 3's?
Yeah, so you guys are on the right path, right? We want to figure out a way to make this look like something that we're used to dealing with, right? So one way to do that is I want to, let's separate this. So let's do it like this. Let's do it like this. Let's say that this is 3 over sine of 3x times sine of 4x. Could I do that?
Yeah.
Okay. So now that I've got it like that, what could I do next?
The 3's could cancel out, so then you just have sine x. Right?
No, this, I have to have an x here.
Wait, why? Oh.
So then, I don't see why
So
if you
can-
have sine on the top and the bottom, why you couldn't cancel out the sine of 3x on the bottom and then get left with 3 sine of 1x on the top.
Well, you're kind of you're heading in the right direction, but your approach is not accurate. Okay. So
This is the shortcut.
wouldn't it be better? Could I put a 4 here if I put a 4 out here? If I multiplied the whole thing by 4, could I do that?
I guess, sure.
Yeah. Now, what would make this a lot easier?
Yeah.
How can I make this equal 1? What do I need down here in the denominator? An x. All right. So could I put an x here so long as I put an x here?
Yeah.
Because if I go through and I simplify, in other words, x divided by x is 1, right? And then this 4 divided by 4 is 1. That will cancel out. I end up with this line right here. So what I could do is I could say 4 times the limit of x as x approaches 0 of sine of 4x over 4x divided by, now when I multiply by this, isn't that the same as dividing by the reciprocal?
Were you supposed to put an X on the bottom of that?
Could I do that?
Forgetting an x.
Wouldn't it be
before.
multiple?
Oh yeah, I'm forgetting the x on the 4. Well, when I divide by a fraction, aren't I multiplying by the reciprocal?
So wouldn't you?
So why'd you put a dividing?
Yeah.
Well, because what I could do is I could say 4 times the limit of x as x approaches 0 of sine of 4x over 4x divided by the limit of the function as x approaches 0 of sine of 3x over x. Couldn't I do that using the properties of limits?
But didn't you just say that you were multiplying by the reciprocal?
Yeah. Why did Mr. Adams need to flip this? Why did I need to flip this?
So that you get the signs on the same.
But what's the limit of this as x approaches 0? 1, right?
Oh, 1 for each, yeah.
And then if I can make it look like this, what's the limit of this as x approaches 0? 1. So what I did is I took something that I knew and I transformed the function to make it into something that I could use.
What happened to the 3x on the bottom of the?
Oh, I forgot to write it down. I'm getting there.
But why, if you said you're multiplying by the reciprocal,
Yeah, why is it dividing?
are you dividing by the reciprocal?
So that you can get 1 and 1.
Okay, think of it this way. Think of it this way. Sine. You guys aren't used to thinking backwards. At least not.
It's the opposite.
Right. So watch. Ready? Sine of 4x over 4x divided by sine of 3x over 3x. When I divide by a fraction, what do I really do?
Multiply by the reciprocal.
I multiply by the reciprocal. Do you see that?
Yeah, but I don't.
When I divide by a fraction, I multiply by the reciprocal.
He's just going down.
Oh, so instead of starting, okay.
Oh, I thought at the top it was divide.
You were just like, oh, we're gonna divide or
You're like,
multiply
we're
by
gonna
the
multiply
reciprocal,
the
and then you
reciprocal
put a
by the
divide, like a
sign.
division sign, and I was like, you're not speaking what you're writing down, but I get it now.
the opposite way.
But either way, it's 1 times 1 or 1 divided by 1. So
Yeah, so we're gonna.
Yes, so we're going to have 4 times the quantity 1 divided by 1, which is
1, 4 times 1.
okay.
Woo!
Can you do
That was easy.
Dang it, I was still missing that.
Does that make sense to you guys?